lecture on denoising. In this lecture, we'll look at how we can... Hello everyone, and welcome to the lecture on denoising. In this lecture, we'll look at how we can denoise by using non-local means or algorithms. Basically, denoising means removing noise, any noise from our image so that our image is clearer, and we'll be using non-local means or algorithms to denoise. So this non-local means they replace the value of a given pixel by an average of a selection of other pixel values. Let's look at an example. So we start by importing the libraries and modules that we need. Import pandas, numpy, matplotlib, scikit-image, and we have the magic function. I copied this from one of our previous lectures. And we'll also need to import data from scikit-image. Let's do that. From skimage, let's import data, and we'll be using the image as float, so I'll import that also. And for our non-local means, we'll need to import the denoise NL means algorithm, which is also in scikit image restoration. Let's do that. From skimage dot restoration, import denoise underscore NL for non-local, and then means that will be the algorithm that we'll use. What we'll do next is look at our Chelsea cat dataset. Okay, and we'll convert it and represent it as float. So we'll use the image as float representation. Then we'll pass our Chelsea data. So we can use the imshow method to check out our cat image. This is our Chelsea cat image. What we'll do next is introduce some noise to this Chelsea cat image so that our image will be noisy. It will have some noise. We'll use numpy's random method to introduce some noise. Okay, let's do that, and we'll save it in a variable called noise. So we'll take our cat image object and then introduce some noise. Let's say 0.4 times, we'll use numpy's random method, random.random, and then we'll pass the shape of our cat object. So this will introduce some noise. And then what we'll do next is we'll use numpy's clip method. Okay, and then finish the introduction of noise. So we'll use numpy's clip method and then pass our noise object, and then let's clip it between 0 and 1. If you are not familiar with the clip method, what it does is it limits your arrays or given values within a certain value. Let me give you an example. Let's say we have an array. Let's create an array using numpy's arrange method. Okay, let's say we have an array x. Now if we call x, we have an array with a list of numbers from 0 to 14. Let me give you an example of the clip method. So we can say we can use numpy's clip method, and let's clip our array x and pass values between, let's say, 3 and 9. So what this means is the clip method will take your array x and then clip it so that all the array values will be between 3 and 9. So that means any values lower than 3 or less than 3 will be replaced by 3. So the values for 0, 1, and 2 will be 3, 3, 3, and then 3. And any values above 9 will have the values 9. So any of these numbers above 9, they will have the values 9, 9, 9, 9, 9. So our array X will be clipped between 3 and 9. That means the values will be limited between these two ranges. Okay? So now, here you see any values lower than 3 have the values 3, and any values above 9 have the values 9. So that's what clip does. So clip does the same thing as I showed here. Okay, now that we have introduced some noise, if we try to check out our Chelsea image using matplotlib's imshow method, then pass noise, we'll see that there is some noise in our image, right? It's not very clear since we introduced some noise. What we'll do next is use the denoise NL or non-local means algorithm, and then try to get or remove the noise from this Chelsea image. Okay, let's look at an example. Let's see how we can do that. So we'll call the denoise method denoise NL means method, non-local means method or algorithm, and then this method accepts certain attributes. So the attributes it accepts is your image, the patch distance, patch size, and height. So those are the main attributes that it accepts. Okay, so for that, let me go to skimage denoise non-local means method. So those are the attributes it accepts. It accepts image, patch size, the default value is 7, patch distance is 11, height, multi-channel, and then fast mode. So the patch size here, it's the size of patches used for denoising, whereas patch distance is the maximum distance in pixels to search your patches for denoising. And you have your height, fast mode, multi-channel, and so on. So you can read more about it here under the scikit image documentation. Okay, now that we have an idea, let's pass those attributes. So we have our noise for our image, we have our noisy image, and then as you have seen for patch size, I'll pass 7. For patch distance, let's pass 11, and for height, we'll pass 0.1, and let's set the multi-channel attribute to true, and we'll save this in a variable called, let's call it denoise. Now that we have our denoise non-local means algorithm, let's plot our noisy and non-noisy or denoise image side by side. For that, we'll be using the subplot method and the imshow method. Let's do that. So we'll say figure, and then axis, let's set it to be equal to plt.subplots, and then let's pass number of columns equal to 2, and then let's set our fig size. What shall we set it to? This is optional for figure size. Let me pass 10 by 6. Now that we have this, the next thing we need to do is use the imshow method and then represent the noisy and the denoise images. Let's do that. So we can say axis, and then for the first one we'll index 0, then simply call the imshow method on it, imshow, and then pass the noisy image, and let's add some label or title to it also. So we can call the set title method set underscore title, and then pass noise image, And let's do the same for our second image, for the denoise image. So index will be 1, im show, then pass our denoise image, and let's set title to it also. So we'll call the set title method, set underscore title, and let's pass denoise nl means or whatever. Okay, let's also call the type layout method, type underscore layout for better visuals. And finally we have our plt show method. Let's run it and see now. Okay, so we have our noisy image on the left and the denoise by non-local means image on the right. You can clearly see that the noise has been removed by using the denoise non-local algorithm. So this example is to show you that we can remove noise by using one of the algorithms known as the denoise non-local algorithm or means. What you can do is change this values for the attributes like patch size and patch distance and height, and see if you can come up with a denoise image and compare it to the values you have here. And once you do that, there is an example on scikit image documentation. For their subplot methods, they use they pass other attributes also, and then see if those attributes give you a better result or not. Okay,